So we're going to talk about Waterline data. The goal for founding Waterline data was to help people make sense of their data and find it. There's a lot of talk about big data, about Hadoop, about data science. And you can think of data scientists as brain surgeons, right? They do very sophisticated things. And as any doctor, they need water. They need water they need data, which is effectively their water that's in a data lake. And today they have to use buckets to go to the lake and bring their own water. And it's dirty. It's really not very productive way of doing it. So we started the company in 2015. It's funded by Menlo and Sigma Ventures. And the founding team basically came from data backgrounds. I've been doing data for a good 30 years, before it was sexy, I have to say. And the rest of the team, Jason ran Teradata Engineering. Oliver was at Informatica and IBM and so on. Lingling did a lot of research at IBM Hamilton, so a lot of data experience. And we're also working with a lot of advisors, everybody from Google and LinkedIn, who actually solved the problem internally, to large companies like Kaiser and Wells Fargo, to all the distributions, Hadoop distributions and other big companies. We've been recognized in the market. We're very thrilled to be TiE50 finalist, but as well as recognized by Gartner, Forrester, and other. So if you think about how people deploy big data and build data lakes, they start in one of two ways. They either start with, okay, we have this expensive data warehouse, let's move it to Hadoop, it's a cheaper platform, more flexible platform, and then grow it. Or they go to analytics and then keep expanding. Either way, they end up with a data lake, which means, imagine your computer has millions and millions of files. You can't open a file, right? This file is too big to open in Excel or look at it. You have to write code to even look at the file. How do you find anything? How do you manage it? So that's the problem we're solving. Remember, we have the brain surgeons on this side, right? The brain surgeons like to analyze, they like to predict, they like to wrangle, they like to work with data. And we have a data lake on the green side with millions and millions of files. So the process we go through, we crawl the cluster, we inventory, and process each file, and build a search index so users can find and understand it. I'm sorry, gentlemen. Can I ask you to, please? Find and understand it, and then provision it for use as a Hive table so you can use analytics or for other purposes. So this is our view of what Hadoop looks like today. I mean, to find anything in that system, you have to dig. You have to ask people. Where is a good data customer list? Oh yeah, well, it's in that directory. Is that the best one? You don't know. You have to ask, you have to dig, you have to really invest a lot of time. It's error-prone, it's inefficient, and it causes problems for everybody involved in the ecosystem, from data scientists and IT architects to governance people who are paranoid about opening this up because they don't know what's inside. If you heard DJ Patil talk about security and privacy, it's a big concern, and it's heavily regulated. So if you open this up and there's sensitive data, that's a problem. So instead, we're going to make it like shopping on Amazon. You inventory, you find, you provision. So our product is built around that principle, where we crawl, we build the inventory of the data, we let the analysts find and annotate and collaborate on finding it, and then we provision it as tables for their BI tools. I'm not going to drill into details of the file of the product, but basically it helps you very quickly find the data that you need. It gives you very nice graphical understanding of what's inside the data, and it helps you annotate. So analysts actually today take a file and take a lot of notes in their notebook. Nobody can use it. They can't find it later. We'll let them attach it directly to files, make it searchable, make it shareable. And with that, we'll basically solve problems that are inherent to the ecosystem. The complexity and the volume of data is such that humans just can't solve it anymore. I guess we're out of time, or is there time for questions?
No questions here.
No questions, okay. Well, thank you, everyone.
Thank you.